Greetings, it's Jerry here. Check out this device that I've made. This is a battery-powered $20 AI device. So this is wearable, and it uses a microphone here to record all of the conversations that it hears, and then it converts those into text, and you can then chat with that text later on. This is based on the ADEUS-AI open source project, which I consider to be one of the most significant AI projects available today. But my reasoning behind that might surprise you. Thank you to PCBWay for sponsoring this video. So do you want to see it in action? Well, it already is in action. Since I've been doing the intro to this video, it has been recording everything that I have said, and now we can use our mobile phone to chat with that information. The app that you see here is part of the project. So let's ask a question. So what do I think about this project? Wow, okay. It's based on the records you've provided. It seems you're very enthusiastic about the ADEUS-AI open source project, considering to be one of the most significant AI projects available today. Your interest in the project is evident from the personal assistant device you've created and showcased in a video sponsored by PCBWay. You've also made a wearable version of the AI assistant for around $20. How amazing is that? In this video, I'm going to show you how to make one of these devices. I'll take you through the different hardware options, how to set up the software, and I'll give you some insight as to how it works. And hopefully this might inspire you to create your own and even improve this project. If you like this sort of content, please consider subscribing to my channel. Just to let you know, this video is going to be broken down into many different sections, and you'll find links in the description to jump you straight to each of those sections. So join me, this is going to be exciting. So why do I consider this project the ADEUS-AI project? And I apologize that I'm going to be saying that wrong. But why do I consider that this is so important? Well, part of it is because there's so much misinformation about AI at the moment. You've got a whole bunch of people trying to make money out of this and promising things that simply don't exist. The AI wearable market is something that's about to explode. There's been a lot of talk about it and a lot of promises made, which quite frankly are ridiculous. And also, once you hold something in your hand, then you can really talk about it. You know, you can take this to work, you can take it to school or university and say, look, this is the reality. You know, some people are going to be disappointed by the reality. Other people are going to be amazed. I think that you can consider this project as like a Lego block, as like Meccano, as something to build upon. Because it is open source, you can take this project and you can expand it. You can find your own niche for this, because I'm certain that there are niches where this type of device will actually be important. You put this in front of someone, you have a conversation while it's turned on, you go and you check out what it's doing, you know, and you will discover that there are certain things it won't be great at doing. But then again, you might find some incredible uses for it. That's enough evangelizing for the moment. Why don't we get on and build this device so that you can experience this for yourself? So we're at the ADEUS GitHub page, and we can just go down to the documentation to get started, and then we'll go to the getting started guide. So there's essentially three things that we need to take care of. One is the back end, the super database. That's the database that does the work, and then we have the web and mobile app. There's not much to do there. And then we have the hardware. So that's going to be, in our case, the Raspberry Pi, but it could be a number of different hardware options. Now, because the documentation is so good with this project, I'm pretty much going to skim through all of this, but I just want to go through everything so that you get an idea. If you're perhaps new to this sort of technology, it's good to see someone do it. And also, I'll take some time to point out some gotchas that that might pop up for somebody who's not used to doing this sort of thing. So the first step is we need to set up the SUPABASE instance. So SUPABASE is an open source database. It's hosted on the internet and we're going to use the one that's hosted on the internet for convenience, but keeping with this project's open source commitments, they've chosen a database that you can also install locally on your PC. So we're using the internet one for convenience. There's a free tier which will be perfectly fine for what we're about to do. So we need to go to the SUPABASE website and we need to create a new project. So I've already created a new profile here, particularly for this demo, and we just need to create a new project. Okay, so once that's come up, give it a name. Okay, need to type in a password and choose your region, whatever region is closest to you physically. So if you're in America, you would choose one in America, because it might be just a little bit quicker for you. And then create a new project. So that'll take a little time to spin up. Okay, so we've created the new projects. It says once the project is created, you should get these keys. So the anon public API key and the project URL. Copy them both as we'll need them in a bit. Yes, we can always come back to the website and actually get that information as well. It's something that's always going to be there. So now it says go to the authentication tab, and we need to add a new user. So we'll come over here to authentication and then add a new user. So we need to create a new user. I've already got this email address set up, and we also want to make sure that auto confirm user is ticked so we don't have to bother confirming via email. So that's all good. So that's all we need to do on the web page for the moment. We need to go back to the PC and do some stuff. Now we're going to need to go to where we've cloned the Git repository. If you haven't already done that, go ahead and do that. And we need to start a command line. Okay, from there, so I've already downloaded and put my repository in my downloads folder, so I just need to, we need to change to the SUPABASE subfolder. So let's have a look. Okay, there's another subfolder and then the SUPABASE folder. So that's where we're at. Have a look in there, just see what's in there. A couple of files are in there. Okay, so then it says install SUPABASE and set up the CLI and follow this guide here. I won't take you through that, but it's a pretty comprehensive guide here. And then we also need to install Docker Desktop, which I already have installed. You'll need to go through the instructions there, but you will need to start it potentially. So I'm just going to run Docker Desktop to make sure that the service is starting and running in the background, because that's the thing that we need to use. All right, so now we have the CLI, we need to log in with our SUPABASE account using the command. So SUPABASE login and press enter. And now that's logged us in and created an access token, which we don't need to be worried about for the moment. Okay. So let's get back to this. And then it says, now we should link to the specified project. So we need to create a link. So we can type in, I'm pretty sure we can just type in SUPABASE link, and it will come up and show us what we can link to. Okay, so it's come up and it's found our project. It's the only project that's there, so we'll just press enter. And we don't need to put the password in, I don't think, but I'm going to anyway. Okay, so what's next? Now we need to apply the database schema. So we've linked to the database that's running out on the internet, and now we need to actually create the database tables in there. So we can just type in SUPABASE DB push, and that should have created the database tables at the other end. And we need to deploy our functions. So these are the things that are actually going to do the work, and it's just a matter of copying that and punching it in. Okay, so that's set up our database. Now the next thing we need to do is they're talking about if you're going to use OpenAI as your foundation model provider. I am going to do that. So this is the LLM that is going to be interpreting the text when we convert the speech into text. So you want to get your OpenAI key if that's what you're going to use. Okay, so that's my key. And that is going to set that as a secret at the other end on the website. I'm going to remove that, so don't worry about the fact that you can see what my key is. It's going to be removed before I release this video, so no one can take advantage of it. Now, what they're saying is that there are other models that you can use, and you can even install them locally on your PC, and there's a guide here to do that. But for convenience, I'm going to use my OpenAI account. Now, the thing about that is it is going to cost me. The more that I use it, it's actually going to cost me money. Whereas if you install one locally on your PC, even though it might not be as good and it might be slower, it won't cost you a cent. And of course, your data is private. That's one of the things about this project. The aims of this project is to keep everything private. Okay, so that's it. So we've set everything up and running. If you just want to take a look, I can show you that if we go down to the database, we can see that there's a couple of tables that have been created for us. One to keep the conversations in and the other one to keep the records. So that's the data, where it converts my speech into text. And the other thing that we did was these edge functions. These are the functions that get run to do the work. So we've got a chat function and we've got a process audio function. And so they've all been deployed to this project. Before we go too much further, let's get the hardware out of the way. So I'm using a Raspberry Pi Zero. So if we go to the how-to guides, you'll see a section here on hardware. This bit here is describing develop without hardware, so you don't even need any hardware besides your PC. You can do everything on a PC with a USB microphone. The ESP32 setup, but we're going to be using the Pi Zero. So we'll go through that, but also this section here on how to assemble the hardware. So with the Pi Zero, we're going to connect a microphone to the Pi directly, and we're going to be using a lithium battery powered board supplied by PCBWay. And in this section, it's talking about using a Pi, what is it called? A Sugar Pi, which is a good idea. That's a good gadget. That's pretty much the same as what I've got on mine. And really, it's just about connecting the microphone to the Pi. And the microphone that I've purchased is this one here. You can see here this round microphone. I'm going to pretty much follow this guide here, except I don't have a Pi Sugar. I'll be connecting it directly to the board that I have, and I'm going to solder the wires directly onto the top of that board. So let's get into that. Okay, so I found some DuPont wires. So the idea is that we're going to attach this here temporarily for our test, and then we're going to solder the wires directly onto the back of this. So I think we can give ourselves a bit of room. These are great wire strippers if you are interested in wire strippers. Pretty reliable, not terribly expensive. Makes it a lot easier to have reliable wire strippers. Yeah, so from memory this was about $50 Australian, so I guess $34 US or something like that. Wacom tools, really German engineered, 100% reliable so far. I've never found a set of wire strippers that works on every type of wire. This one works on practically all of them, but if it's too thin, if it's it's very, very thin or very, very thick, then this isn't going to work. But for 95% of all wires I come across, this is the perfect tool for the job. Okay, so we just need to tin all of these wires. Okay, and then these are going to attach directly to these pins. So these wires need to be as short as possible. So I'm going to cut these right back so that when I solder them on, they're not in danger of shorting out. So I don't know if you can see how short they are. Maybe that's not even short enough. So it's just a matter of soldering these wires onto the back of these pins here, according to this diagram. Okay, so they're all connected up now. It's a little bit long at the moment, but that's okay. We just want to get this up and running first, and then we can think about how we're going to position the microphone, or any of that sort of thing. I suppose it could go in there. How's that? Yeah, we could just slip the battery in there, connect it up. Got ourselves a nice little package without even trying. So I just wanted to talk a little bit about powering the Pi Zero and how I went about it. So the board that's on this was provided to me by PCBWay. PCBWay don't just provide PCBs, they will provide you with fully assembled PCBs. So they actually provided me with this board with all the components already soldered onto it. Thank you very much, PCBWay, because that saved me quite a bit of work. So this is a lithium battery charger that also powers the Pi, and I got this from PCBWay's projects page where somebody had uploaded this design. I'll leave a link in the description about that. But there are plenty of other options you can choose if you want to power a Pi from a different power source. So in the documentation on the ADEUS website, they talk about using a Pi Sugar. That seems like a really good gadget. You can get those off Amazon, and that's very similar. That's a board that slots into, or it's what they call a hat that slots into the Raspberry Pi Zero headers and provides a battery. Theirs is quite enclosed, looks quite a good product. I have another one here which is fairly old. It's called a Pi Z Uptime, and it's a similar concept. You plug that in, and when you power it on, it charges this battery. The only advantage being, of course, you can pre-charge all of your batteries and then just plug it straight in if that's what you wanted to do. Of course, the simplest way to do it is simply to get a power bank and plug it into the Pi directly and skip this board here. The only thing is though that you need to mount your microphone. In the case of this, I've attached the microphone to the top of the board here, but you can just connect the microphone directly to the pins of the Pi if you wanted to just use something like that. So there are plenty of options there. Another really cheap option is this. So this is a LiPo charging board. You can buy these off eBay for a couple of bucks maybe, and you simply have to solder your battery onto that, and you can charge it up. So it basically does exactly the same thing as this, only you can't mount it to the Pi. Speaking of which, these Pi Zero proto boards, which I also got from PCBWay, I was thinking about doing exactly that. So with these boards, I could actually put the headers on so that I can put the proto board directly onto the top, and then, you know, I could mount this little charging board there and perhaps put the battery on there. And that's something maybe I'll do in another project. But like I said, there are heaps of options to power this to make it portable. So let's have a look at the Pi Zero guide. All right, so we need a Raspberry Pi. Sounds good. We need an SD card, 8 GB or larger, internet connection, access to a computer with an SD card reader, and we need a clone of the software, which we've already done. If you haven't already done that, you want to go to the GitHub repository and hit code download zip, and that will give you everything that you need. All right. So they're saying now download the OS image. So we want to use the Raspberry Pi imager. Okay, so this is the imager provided by the Raspberry Pi Foundation. So we'll choose the device. Now I've got a Raspberry Pi Zero, not a Raspberry Pi 2.0. So we'll do that. And then for the operating system, they say download this particular one here from this link. I've already tried that on my Pi Zero and it doesn't work. So perhaps that's only specifically for Pi 02s. So instead of that, what I'm going to do is I'm going to choose this Raspberry Pi OS Other, and we will go and choose Raspberry Pi OS Legacy 32-bit Lite. So that's the bullseye, and the image that they want to use is bullseye as well. So this is a 32-bit bullseye. And we're choosing the Lite version, so it doesn't have a desktop environment, so it will be much smaller. And then of course we need to choose the storage. Be careful here. I've got 2 USB drives plugged in, and one is a 2 GB hard drive and the other one is my 16 GB SD card. So we'll choose that. And at this point we want to go in here and edit the settings, and we want to enter in all the relevant information. So we're going to call this computer on the network ADEUS.local. This is the username we're going to use and the password, and this is the configuration for my Wi-Fi at home. Now this is very important down here where it says wireless LAN country. You need to choose the right ID for the country that you're in. I'm in Australia, so it's AU. And if you're in America, you would choose something else, or if you're in Germany or something like that. If you don't choose the right country, it basically won't connect to your network. So we've got that. So that's going to connect automatically to our network. And in the services, we want to enable SSH using password authentication. and the rest of it's just the same. So we want to apply those settings and then write that to the SD card. Just make one more check that that's the right SD card, and away we go. Right, so that's finished. So we just need to put that SD card into our Raspberry Pi and boot it up, and hopefully it will connect to the network. I've noticed that my Pi is quite slow. It's one of the old ones. I'm not sure about the newer Pis, but you want to give it a good 5 minutes after it first boots up. Maybe even 10 minutes for it to boot up completely and get connected to your network when it's being run for the first time after it's been imaged. I've given it enough time to boot up now, so I just want to make sure that we can get to it via the host name, because sometimes this can be a bit problematic depending upon how your network is set up at home, if that's where you are. But we should be able to ping it. So we open up the command line parameter and we go ping and use the host name, and hopefully it will find it on the network, which it hasn't. The other thing we can do is try removing the local and see whether that's any better. Okay, so this happens quite a lot on my home network. On my work network, there seems to be no problem with this. It's something to do with the way that Windows is set up. So this does not mean that the Pi is not on the network. But the first thing I would make sure is that you have set it up correctly. When you were imaging it, that you put in all the correct details for your Wi-Fi network, etc., etc. If you're confident about that, there's a couple of things you can do to try and find out whether it's on the network. If you're on a home network, you've probably got some sort of config in your router that you can look to see what computers are connected to it. The other thing is you could put a monitor and a keyboard onto the Pi 0 and then log in using that and ask Linux what its IP address is. That's another way of doing it. But here's the way that I do it. I installed this program called Angry IP Scanner. I know it sounds ridiculous, but basically you put in the address range of your home network and you hit start, and it will go out and it will find every computer that's connected to your network. And it will also tell you the ports that are open on those computers. It's very, very handy. And you can see here that it's actually found it. And it's got port 22 open. So that's the SSH port. So any computer with the port 22 open is going to be potentially the computer that we're after, and I've got a whole bunch here. So if a computer had have come up here and it didn't have a host name, but I saw that it had port 22 open, then I might try connecting to that computer. So we can't use the host name for some reason, but we can look at its IP address. So we can see here that the IP address is 192.168.68.132. So in the instructions, wherever they say, for instance, here it says we're going to SSH to it, putting in the username and then the name of the computer. We won't use that, we'll use the IP address. Now we need to make the SSH connection to the computer. So we start up a command prompt and type in that command. So SSH, then the username which we chose when we were setting up the Pi. So ADEUS and we're going to use the IP address 192.168.68.132. So the first time you do connect to it, it says this thing about the fingerprint, and you just type in yes. Okay, then the password. And we're in. So if you've never used an SSH client, what's happened here is we've made a remote connection to the Pi 0. So all the commands that we type in now are actually happening on the Pi. So even though we opened up a Windows command prompt, we've started an application called SSH, which has connected us to the Pi. So now everything that we type in, like ls is a Linux command, is happening on the Pi. And this can get a little bit confusing if you've never used this before. And plus we're going to need to do some things in the Windows command prompt. And I just wanted to make it clear that this particular one here is happening on the Raspberry Pi. And we don't want to get confused about that. Okay, so we've made our SSH connection to the computer. The next step is we need to copy over all of the files needed for setting it up on our Raspberry Pi. And so we're going to be using this command. So you need to find out where the project files are that we downloaded from the Git repository. So in my case, it was here. And we've got a subfolder there called devices. And we've got the devices that are supported. Oh, there's a Pi Pico, haven't seen that before. But it's the Pi 0 folder that we're after. Okay, so this is the application that needs to run on the Raspberry Pi that does all of the work. So this is where it is. So I'll just copy that address from there. And I'm going to start another command line. This is why I wanted to make sure that we didn't get confused as to what we're doing. So this is a command line that's happening on my Windows PC. This is not the SSH connection. Okay, so we need to type in this command, scp -r, and then the path that we just copied to our Raspberry Pi folder. So this is basically saying copy all of these over the SSH connection, make it recursive. I'm not sure if we need that, but this is the folder where we want to copy all the contents from, and then we need to put in our username for the Pi, and then we need to put in the host name, or in this case we're using our address because we can't do that, and we want to put in a colon and then a tilde, which is the little key, it's the key above the tab, so shift to get that, and /. And it's basically saying copy it to the home directory of the user ADEUS. Put in our password, and it has copied those files across. Cool. So I'll minimize this and I will maximize our SSH connection across there. So if we do an ls now, so list, we can see that we have a new directory in there. And if we change to that directory and do an ls, we should see that those were the files that we copied across. Okay, so we've fulfilled this, transfer project files. So install dependencies. So we've changed to this directory, and then we have to issue this command. Oops. So chmod +x on the install sh, that just basically makes the install.sh script executable, and then we need to run it by /install sh. Okay, and then it should go off and do some stuff. So I think what it's doing now is it's going to download all of the packages that it's needed for setting this up, which may take some considerable time. All right, so it's done that, and now it's come to this point where it's saying, do you want to auto load the module for the I2S microphone support at startup? And the answer is yes. Otherwise, every time we booted the Pi, we would need to manually install that module or load that module into memory. That's done. So it's asking us, do we want to reboot? And we want to say, no, we don't. Not at this stage. Now it's prompting us for the information about our SUPABASE instance. So we can go back to that to get that information. We just go back to the home screen of that project. And here's the project URL, which we can copy. And it wants the token. And that's this token here, the anon public token. Fantastic. All right, so now we need to reboot it, I believe. Yeah, so reboot your Pi. So to reboot it, we type in sudo reboot. And that's going to reboot the Pi, and it's going to kick us out of this SSH shell. And it might not realize it's been disconnected. So you might have to press the enter key or something like that for it to realize that the connection is now broken. Okay, so I just wanted to point that out. So you can see here that where it was saying ADEUS at ADEUS, the command line has now gone back to C/users, right? So we have exited out of the SSH client. We're now back in the Windows command shell. That's very important to understand. So once the Pi has restarted and connected to the network, then we can reconnect again. Okay, that took quite a time. That took quite a while to come back up, but there we are. So what's the next step? We've rebooted. We need to run the application. So we'll change back into our directory. So devices. Okay, so we're back in here, and it says chmod the compile sh, and then /compile sh to run it. So this is now going to compile the main.cpp source file into a binary, which may take a little while. Okay, so the compile is finished, and that has given us a binary called main. So if we just look there, you can see that there is in green, which means it's executable, there is the main binary. And the main C++ file here, source file, was what got compiled. In actual fact, if you're interested to see how it works, you can just have a look at the source code for that, and you'll be able to see exactly what is inside this binary, how it's recording the audio from the microphone. And I think if we go down here, we can see that this actually takes some command line parameters. So this binary, there's a help command that, so there's an option to save the audio file locally, and there's the gain, the microphone gain, to increase the volume of the audio. So interesting stuff in there, well worth a look. But let's move on. So after we've compiled it, they're saying You can start it in debug mode by running gdb and then the binary. We wouldn't want to do that, I don't think. We just want to run the binary itself. And so once we run the binary, it will immediately be listening on the microphone, and anything that it detects, it will record and send up to the SUPABASE instance, who will then send it off to OpenAI to be converted from audio into text, and then do all of that magic that allows us to chat with it. So we can run it by typing main, but I am interested to see the command line parameters. So would that be minus help? No. Minus help? Yes, so minus help gives us the options. And so we can actually start this and get it to save the audio to a local file, which could be very useful, and also set the gain of the microphone. We won't be doing any of those things though at the moment. We just want to run it and see if it works. So /main should run the binary. All right, and in theory, that should be it. So right now, if I come a bit closer to my device and I start talking into it, it should record. Hi, my name's Jerry. I'm a software developer living in Melbourne, Australia. I live in the eastern suburbs in what's known as the Green Wedge, which basically means I'm in the middle of the bush. We have animals like kangaroos and wombats and things wandering around our property. We also have rabbits, which are quite a bit of a problem for us. We live on a couple of acres, and I enjoy a lot of gardening, as you can imagine. Okay, so I had a good chat with it, and let's come back and have a look to see what it's done. So it's putting some debug out here. So it's talking about connecting to the SUPABASE instance on the internet. And finally it says, did it say something there like we have completed uploading? Yeah, we are completely uploaded and fine. So I guess that means that it has listened to what I said and it has sent it online. So why don't we go back to this instance here and have a bit of a look. So if we go to the tables and we go to the records, we can see, hopefully, that should be what it recorded me saying. Look at that. So it worked. That is very cool. So in theory, we should be able to go and chat with that information that's now in the database. Let's move on to testing the mobile app. So the mobile app is going to run on our PC, and we're going to connect to it from a web browser to the local PC or from a mobile phone to this PC, and we should be able to talk to our data. Okay, so let's run the app. So change to the app directory and run these commands. npm I. Okay, so it looks like we need to install Node, JavaScript, if we want to run that app on our local Windows PC. Okay, so this is installing Node.js. Okay, so let's type in npmi and then npm run dev. Nice. Okay, so I guess we need to connect. Okay, so now we're running a local copy of the chat app. And it's still going to require our SUPABASE details, which we can get from here. All right, so what is my name? Well, yes, okay, it is. What else did I say? I said that, so where do I live? That's fantastic. What animals live on my property? Absolutely spot on. Fantastic. All right, I guess we'll leave the video there. So just a quick reminder, I'll leave links to all of the things that I've discussed in the video in the description. Check that out. Also, please consider subscribing to my channel, leave me a thumbs up, a comment, all of that good stuff, and I'll catch you on the next video. Ciao.